Hi everybody, Miss Calabrese here. In this video, we are going to introduce you to your lymphatic system. All right, so your lymphatic system is a series of vessels that's kind of similar to the cardiovascular system that we talked about last time. But the lymphatic system, instead of being a closed system of tubes attached to a central pump like your cardiovascular system, this is an open-ended system that really only moves in one direction. The functions of your lymphatic system are to drain interstitial fluid. So that's the fluid that accumulates in your tissues between the cells that kind of leaks out of your cardiovascular system. Lymphatic system is also going to be important for moving lipids. So the lipids that you eat when you eat fat-containing foods, those lipids don't get absorbed directly into your bloodstream. They have to get absorbed into your lymphatic system first. And then the lymphatic system is also going to be incredibly important for facilitating your immune response. So lymphatic system and the immune system work very, very closely together. All right, so major components of the lymphatic system here. So we've got a lot of vessels, so capillaries, vessels, lymphatic trunks, and ducts. So these are all some big, some small vessels that are carrying lymphatic fluid in one direction, and that is towards the thoracic cavity. All these vessels, whether they're large or small, are all moving in one direction to bring this lymphatic fluid back up close to the heart. All right, so in addition to all of those vessels, we also have lymph nodes and then primary and secondary lymphatic organs. All right, so lymph itself is basically this clearish fluid, sometimes can look a little bit milky, that we find in the extracellular fluid compartment. So extracellular meaning on the outside of your cells. So these extracellular fluids are going to include plasma, right? So remember that every time your heart beats, we're getting a little bit of that blood hydrostatic pressure that's pushing some of the plasma out of your capillaries and into the interstitial space. So that's where we find this interstitial fluid. And then once that fluid gets all gathered up and enters into your lymphatic system, we call it lymphatic fluid. All right, so flow of lymph is always towards the chest, right? So lymph is always being collected from your extremities and moved towards the thoracic cavity. So it's starting as interstitial fluid that's accumulating between your cells, and then it gets sucked up into lymphatic capillaries, which will merge into larger lymphatic vessels. Then we pass through lymph nodes, which act as basically filters. So lymph nodes are going to act as filtration stops for this lymphatic fluid as it moves back towards the chest. So in that lymph node, you'll find lots of immune cells that are there to devour any pathogens that they may find in this lymphatic fluid. Okay. All right, so all of these lymphatic vessels are heading back towards the chest, and when they reach the chest, they're actually going to re-enter the cardiovascular system. So remember that this fluid, this lymph, was initially plasma that got pushed out of the capillaries and into the tissue, so it needs to get back into the cardiovascular system. So that's basically what your lymphatic system is doing, is getting this fluid back where it needs to go. So as we head back towards the chest here, your entire lymphatic system is going to converge into one of two major ducts. So we've got a right lymphatic duct, and that right lymphatic duct is going to be draining lymph that's coming from the right side of your head, your right arm, and the right side of your chest. And then the thoracic duct drains lymph from everywhere else. So left side of your head, left arm, left chest, and both um, lower extremities all gets drained into the thoracic duct. Right, so I don't know why it's asymmetrical, it just is. So that right lymphatic duct is going to join with your right subclavian vein and dump the fluid back into the cardiovascular system there. The thoracic duct is going to join with the left subclavian vein and dump the fluid back into the cardiovascular system from there. So we're always entering the circulatory system at the subclavian veins. Okay, so let's look kind of closely at what these lymphatic capillaries look like. They are going to be a little bit larger than blood capillaries, and they have a one-way structure that's created by overlapping endothelial cells. So the cells kind of um, they almost overlap like scales. And that overlapping system is what allows them to only flow in one direction. They also have many, many, many valves. So remember that we have really low blood pressure in your veins, and that's why your veins have valves. Lymphatic vessels have even less pressure than veins, almost no pressure at all. So we need numerous valves in order to prevent any kind of backflow. Um, and in addition to those lymphatic capillaries, there are also some specialized lymphatic capillaries called lacteals that are associated with your small intestine. So these are tiny little lymphatic capillaries that you find in the villi of the small intestine. They're going to be there to absorb dietary lipids. So lipids from your food that need to get absorbed into your bloodstream don't go directly to your bloodstream. They go into these lacteals first, and then they will go through the lymphatic system and eventually get into the bloodstream in the subclavian veins the same way the rest of the lymphatic fluid does. Um, that fluid that gets absorbed from the lacteals, so the combination of lymph and lipids, is called chyle. Okay, so here's some pictures of what this system looks like. So here we can see a capillary bed. So we have a little arteriole that's flowing to deliver blood to these tissues here. Now and then the blood's going to flow through the capillary bed and then into a venule and eventually a vein and back to the heart. Now the fluid is going to be leaking out of those capillaries because of the blood hydrostatic pressure. Right, so that's going to push plasma from the cardiovascular system out into the interstitium. But some of that fluid is going to be reabsorbed back into the capillaries. So remember, the blood colloid osmotic pressure is going to draw most of that fluid back into the capillaries, but not all of it. So whatever's left over that doesn't get absorbed back into the capillaries is now in the interstitium. That's going to need to be reabsorbed in the lymphatic system, right? So this is where we mentioned that there's about, in the last video, I believe, about 3 liters difference in fluid a day from blood hydrostatic pressure to blood colloid osmotic pressure. So those extra 3 liters of fluid need to be absorbed back into the system somehow, and they do it by going into these lymphatic capillaries here. Right, so lymphatic capillaries then are going to pull that fluid back up towards the thoracic cavity. So right here we can see those endothelial cells with that kind of overlapping structure and how they sort of act as one-way valves because they're not going to permit backflow. And then here we can see an actual lymph node, right? And the lymph node is where we're filtering this fluid and are able to use some phagocytic cells like macrophages in order to eat any pathogens or debris that's been accumulated in that interstitial fluid. All right, so a few questions here. What's interstitial fluid? What is lymphatic fluid? Where do the lymphatic ducts meet the circulatory system? What are lacteals and what is chyle? Okay, so there's your answers. Interstitial fluid is fluid between the cells in the tissues. Lymphatic fluid is the fluid that's inside the lymphatic vessels. The lymphatic ducts meet the circulatory system at the subclavian veins. Lacteals are lymphatic vessels that drain lipids from the small intestine, and chyle is that lymph with lipids that is being drained through the lacteals. Okay, so looking at an overall kind of schematic of your circulatory and lymphatic system together here. So here we can see the circulatory system, the heart with the pulmonary circulation and then the systemic circulation. And then we can also see that you've got lymphatic capillaries that are associated with both parts of the circulation. So anywhere that fluid gets pushed out of a capillary bed, you're going to have a lymphatic bed of capillaries that's ready to pick up that fluid and then carry it all the way back up to enter the subclavian veins, and then it'll be back into the circulatory system at that point. Right. If we have some sort of like obstruction, some blockage in a lymphatic vessel, if we're not getting good flow, that can lead to edema. So edema is the accumulation of fluid in the interstitial space, usually because there's a lack of drainage from your lymphatic vessels. Okay. So in addition to the vessels, we've also got some lymphatic organs that we kind of refer to as either primary lymphatic organs or secondary lymphatic organs, and these are going to be distributed all over the body, and they're heavily associated with your immune response. So remember that the lymphatic system and the immune system work very closely together. All right, so your primary lymph organs are bone marrow and thymus. All right, so bone marrow, remember, is important for the production of blood cells. So all hematopoiesis is happening in that, well, not all, most hematopoiesis is happening in the bone marrow. And that's going to be where we're building not only red blood cells, but also all of your white blood cells, which is why it's important here for immune function. And then the thymus gland is considered a primary lymph organ too, because that is where your T cells mature. Right? So thymus is an endocrine gland, but also an immune gland, because that's where your T cells are going to be maturing and preparing to mount immune responses. Secondary lymphatic organs are where a lot of these immune responses are going to happen after the fact. So after we create the B cells and T cells, then they're going to do their work in some of these secondary lymphatic organs, like the lymph nodes, like the tonsils, and the spleen. All right, so here's your thymus gland. If you can remember back to the endocrine system, we talked about how your thymus gland kind of sits right on top of your heart here. It is variable in size. So in infants, the thymus gland is very, very large compared to the size of the rest of the body. And then it just kind of shrinks with age to the point where in the elderly, sometimes you can hardly even find it anymore. So it gets smaller and smaller as you grow older. But again, this is where T lymphocytes, after they've been manufactured from the bone marrow, will migrate to the thymus to continue their maturation. Right, so thymus we can divide into outer cortex and inner medulla. The outer cortex is where we find these immature T cells. So right after they've arrived from the bone marrow, they spend a lot of time in the outer cortex of the thymus. They are going to then begin their maturation process with the help of dendritic cells. And dendritic cells, remember, are phagocytic cells that are associated with your skin, with the integument. So those dendritic cells are going to help to educate your T cells, so help them mature into actual functional lymphocytes. We also have some epithelial cells here in the cortex that produce hormones called thymosins. So the thymosins are there to help the maturation of the T cells, help guide the T cells to mature. And then in the inner medulla of the thymus is where we find those actual mature T cells. All right. We also have a lot of lymph nodes. So lymph nodes are, again, these little kind of filtration areas. So all of your lymphatic vessels pass through lymph nodes on their way back to the circulatory system, so we can filter out any nasty stuff before we get back into the circulation. So you have hundreds and hundreds of lymph nodes, and we kind of organize them by the general region where we find most of them. So you have a cluster of lymph nodes in your neck. Those are your cervical lymph nodes. A cluster under your arm. Those are the axillary ones. A cluster in the hip and thigh, and those are your inguinal lymph nodes. And then a cluster in the chest that are your mediastinal lymph nodes. So those are the four major clusters of lymph nodes in your body. All right, so let's take a real close look at one of those lymph nodes. So the terminology here is going to be similar to terminology that we use for other systems. So we've got afferent vessels that are moving into the lymph node. The fluid that's traveling through those afferent vessels is then going to be filtered in the lymph node, and then it's going to be carried out through efferent vessels, and those efferent vessels then are going to head towards the thoracic cavity. Right. While that fluid is in that lymph node, though, we've got a whole bunch of macrophages and dendritic cells that are there to phagocytize anything gross that they find. So any pathogens, bacteria, viruses, debris will get phagocytized by those macrophages or dendritic cells at this point. We also find B cells and T cells here. So your lymphocytes are also um, found in these lymph nodes. Right, and then the spleen, secondary lymphatic organ, is divided into white pulp and red pulp. The white pulp is basically lymphatic tissue where we're going to find a lot of lymphocytes and macrophages. The red pulp, this is where we're storing some platelets. It's also where we clean up and destroy a lot of old red blood cells. So a lot of the erythrocytes that your body recycles, recycling happens here in the spleen. So the spleen is a filter as well, but it doesn't operate the same way as your lymph nodes. So the spleen filters blood, your lymph nodes filter lymph. Okay. Some other lymphatic organs here are your tonsils. So you have three different sets of tonsils located in your head and neck. So pharyngeal tonsils or adenoids. Those we find in the posterior wall of the nasopharynx. So if we're looking at a cross section of this person here, we can see these pharyngeal tonsils or adenoids located at the back of the nasopharynx. So right back here. Palatine tonsils, those are at the back of the oral cavity on either side of your mouth. So the palatine tonsils located on the, here they are here, located at the back of the oral cavity on either side of the mouth. And then lingual tonsils are at the base of the tongue. So if we look way down here at the base of the tongue, you can find your lingual tonsils. And so tonsils are basically for filtration and for protection. So if you think about it, your nasal cavity and your oral cavity is where you bring in a lot of stuff from the outside world, whether that's food that you're eating, liquid that you're drinking, air that you're breathing in. This is where it's going to enter the body. So if any of that air, liquid, food is contaminated with pathogens, we've got these tonsils that are kind of ready to fight whatever's in there. So these are lymphoid tissue that's has a lot of immunoglobulins in it, a lot of white blood cells in it that are ready to attack any pathogens that are being brought into the body from the nose and mouth. All right, I actually like this picture a little bit better. So we can see the pharyngeal tonsils way up here. Those are your adenoids, way at the back of the nasopharynx. Palatine tonsils that are on the back of the mouth on either side of the mouth, and then the lingual tonsils that are down here at the base of the tongue. You have lymphatic tissues scattered all over the body. One of the places that we find a lot of lymphatic tissue is in your digestive tract. So remember, digestive tract is bringing in food, and the food you eat is never sterile. Any pathogens that do make their way into the gut will encounter this mucosa-associated lymphatic tissue, or MALT. Sometimes called gut-associated lymphatic tissue, or GALT. So these are just patches of lymphatic tissue that contain cells that are able to catch some of the pathogens that might be passing through your digestive tract. And then Peyer's patches, these are specific patches of MALT that are located in the small intestine. All right, so a few questions here. Do lymphatic vessels have any pressure? How is lymph moved through the vessels? What is edema? Where are white blood cells made? what's in the outer cortex of the thymus, what's in the inner medulla of the thymus, and then what are dendritic cells. So here's your answer. There's little to no pressure in your lymphatic vessels. So fluid is going to be moved through those vessels in a similar way that fluid was moved through your veins. So we're relying heavily on one-way valves and skeletal muscle pump, which is why it's important to get up and move around periodically. If you're on an airplane, or if you're bedridden and sick, whatever, it's important to get up and move around and flex those skeletal muscles to help prevent the buildup of edema, which is fluid buildup in the tissues. Um, your white blood cells are going to be made in the red bone marrow. Um, and then the thymus is where the T cells that are made in that red bone marrow are going to mature. So in the outer cortex of the thymus, we find the immature T cells, and the inner medulla of the thymus is where we find mature T cells. And then dendritic cells are the phagocytic cells associated with the integument that we also find in your lymph nodes. All right, last few questions here. Where is lymph fluid filtered and cleaned? Where are most of your lymph nodes located? What white blood cells are found in the lymph nodes? What does the spleen filter? And what are the 3 pairs of tonsils, and where are they located? Right, so lymph is filtered in the lymph nodes. Most of your lymph nodes are located in one of 4 different regions: the cervical region, axillary, mediastinal, or inguinal. The white blood cells found in the lymph nodes are going to be dendritic cells, macrophages, and we'll also find B and T cells there. The spleen filters blood, and then your 3 pairs of tonsils and where they're located. So your palatine tonsils, at the back of the oral cavity, your pharyngeal tonsils or adenoids, those are at the back of the nasopharynx, and then your lingual tonsils are at the base of the tongue. All right, so I hope that was helpful. Let me know if you have any questions.